Welcome everybody, and hello, and please take a seat in our virtual Innovation Showcase event. Very excited to see you here this morning. My name's Simon Woodward. I'm the chairman of the UK District Energy Association. I'm here to provide a quick intro to the day. So without further ado, as we want to keep to time, I'll move on to the first slide. Just a quick one about who we are. We're a non-trade, not-for-profit association. We've been running for over 10 years now. We had 6 founder members, mainly local authority-led schemes, started us in the UK, and we're now approaching 130 members, and we're growing rapidly. At the core of our scheme are the scheme developers, owners and partners, and around those sit the very important equipment suppliers, consultants, contractors, service providers. And all major district energy schemes in the UK are represented by the UKDEA. So just a quick spin about what we're about, what you get if you did decide to join us. Through us, your voice is heard in central government. We're regularly engaging with central government. I've had 2 meetings this week with senior representatives from central government. You'll receive regular updates on both existing and emerging national policy and regulations. A 50-page monthly journal. There's an image on the right-hand side of our January copy. You'll be able to attend the annual conference, the AGM, be involved in regular networking events, gain full access to a feature-packed website and library, and most importantly, receive help, advice and support. So if you're not a member and you're attending for the first time today, attending a UKDEA event for the first time today, please do consider joining us. So today is a bit of a different event for us. We've never run one like this before, so it'll be very interesting to see how it works. There are 200 registered delegates, so we're expecting quite a lot of a chat and questions. There are 4 key themes that we set the day up to, which has been in the flyer. There are 15 presentations across that day, all of them putting forward an innovation that that particular organisation has developed. Each of those organisations have 6 slides and no more than 10 minutes. I'm afraid I'm going to have to be quite brutal, so apologies if you think I'm being a bit mean to speakers who are potentially overrunning. If you want to ask a question of the speaker, please put it in the chat. If they finish early, if they finish at 8 minutes, 9 minutes, we'll try and get some questions to them during the event. If they finish at 10 minutes, I'm afraid we won't be able to ask questions today, but we will get those responses after the event for you. And I think the really important thing to remember, today is not a full-blown presentation on what they offer. It's about a taster for their innovation. So if you want to find out more, please contact them. So without further ado, I would invite Neil Parry to come onto the stage, and that's enough for me, Simon Woodward, the chairman. So Tom, if you don't mind putting Neil's presentation up, that'd be fabulous, and I'll hand over to Neil.
Thank you, Simon. Thank you to everyone who's come along this morning to have a look at this. I'm going to break precedent straight away, and rather than do 1 innovation, I'm going to try and do 2 and fit it in 10 minutes. So apologies if I go a bit fast, but I'm going to try and finish it with some questions space as well. So 2 things I want to look at. Instantaneous hot water generation from a HRU, which everyone knows about, but the innovative part is the electric boost that potentially you can have on the primary side of a HRU for when you're looking at really low temperature networks. And then I want to look at remote connection to HRUs, remote control of that HRU, setting of functions and so on, and then also seeing what performance is happening on the network. So I'm going to look at both of those things, hopefully. So the first one, the table on the left is just straight from CIBSE CP1. And what you can see on the right-hand side of that table is typical power demands, domestic hot water demands for a typical apartments shown on the left at different types. Now you can see the top right calculation from our SATK 32107. If you have a 55 degrees C primary flow going in, you've got 44 kilowatts of hot water instantaneously from the unit. Now that covers pretty much the majority of these, all except the 3-bathroom apartments where we're pretty close. But what happens if you start to lower that temperature? And here in the second calculation, we have 51 degrees C, so a lot lower. Now we're down to a 1 degree approach, not normally recommended, but you're down at a very low temperature, and you can see the output potential from the HRU drops to just 30 kilowatts. So we now miss some of the larger apartments here. So what do you do when you get to to that situation where you need a bit more output from the unit. You can't go below that 1 degree approach, of course, otherwise the plate heat exchanger just won't effectively work. So what do you do? Well, that's where we come in with this. This is an immersion cylinder. It's like a tube, if you like, which sits onto the primary feed into the HRU. Now, crucially, it is connected to the HRU, and the HRU controls it, and that is crucial. Because under normal circumstances, if the apartment has heating on or it's in standby, the immersion is doing nothing. It's just sitting there, dumb, if you like. Now, when a tenant turns on a hot tap or there's a hot water demand, the HRU recognizes that, of course, and immediately starts to open its control valves in the normal way, but it also energizes power to the coil. And that has the ability to lift the temperature of the primary water coming in by up to 10 degrees. And we size these to suit the project. So you can now have a primary flow or district flow that is below the temperature that you actually want on the hot water side. Because say if you're coming in at 45 degrees C, getting a really good COP from your heat pump, we can lift that to 55 instantaneously by the electrical energy into here. And then the HRU can produce your hot water at the right 50 degrees temperature with enough output. Now, crucially, two things. One is that this is controlled by the HRU. It's only energized when you have a domestic hot water demand. So your additional electrical load in the building is diversified in the same way as you would do with DS439 for your domestic load anyway. So the additional load is really very, very small, additional electrical load. So that's the first aspect. And the other very important point is we put this coil on the primary side or on the feed into the HRU. And the reason we do that is you maintain your delta T on your network. If you have this on the secondary, if you, i.e. put it on the outlet of the domestic hot water from the HRU, or you put it in a cylinder, if you like, and connect to a cylinder and store your domestic hot water, you will reduce your delta T on the primary side with all the negative connotations that has. Doing it here on the feed into the HRU maintains that delta T. So you have much smaller flow rates, less heat loss, less chance of overheating of the building, smaller pipe work, all those things that cascade down from that. So that's the first item I just wanted to share with you. The second one is Modbus connection and control. What I'm showing here is the head-end software from our Modbus. And what we've tried to do with this is simplify it. So you don't have to be an engineer to see what's going on. And that's why we have these very simple with traffic light speedos, if I word them that way. And what you can see here, this is just a snapshot of one particular apartment. We can see this would all be instantaneous live data from your project. And you could have 100 HRUs, 300 HRUs, doesn't matter, all connected. But this is looking here as an individual HRU. You'd access on the menus on the left-hand side all the system data, so the energy data for billing, but you'd also see things like what's happening in the plant room and so on. But what you can see here is a flow temperature, roughly 66, 67 degrees, return temperature on your network as well, then the delta T summarized, and then here differential pressure. You have fault coding at the top, so if there's a fault on the HRU, it'll come up and tell you, give you a warning, and that can be linked to alarms that are automatically sent out either via an email or via text message for somebody to actually do something about it. And the parameters for those alarms can be set, so you can tailor them to suit what you want to do on your project. Then it tells you a little bit here about what the HRU is doing, what mode it's in. If it's in here, it's green, showing heating and domestic hot water, but you could have hot water only or standby. And then you have some of the more advanced features that we have on our SAT-K range, where you have return temperature limitation, you can have weather compensation, pasteurization included. There's all kinds of things. Primary flow rate limitation is a real good one, but it'll tell you what mode that's in. And then here in the graph in the center is historic data that goes back as long as the system's been running. And you can go back, you can see what's happening to the delta T. You can graph many things on here. Anything that's being read by the Modbus, which is up to 250 bits of data. You can see it, you can just pull them out and put them into the graph and graph them and see. So whichever parameters you want to view, whatever you think is important to you, you can show on this graph and see what's happened. And then you can simply zoom in, and then it's averaged out or shown in the table here what the maximum, minimum and average values are, and so on. The final bit on this screen here are some of the things that you can set. So you can see the top one just says domestic hot water temperature. It's currently set there at 50, but if you wanted to change that, you simply go in there, change it, and it will actually update that to the HRU. In doing so, you can, for instance, change any of the settings that you can do in front of the HRU, you can do remotely on this software. So you can activate all those advanced features or change them or modify them. You can put preheat on, you can turn it off, you can time it, you can do whatever you wish. You also have the ability to set parameters that can't be changed by the tenant. So you could go in and say, well, I want 50 on that HRU, and I don't want the tenant to be able to change that. And you can then set that in, and the software will make sure that that never changes from 50. So it's really flexible, gives you the option to do whatever you want to do. We can also include bulk meters from the plant room into this. We can include temperature sensors on the network, differential pressure sensors on the network, anything that has a feed from it, we can actually take into the software and display it graphically in this way. And it's very easy to tailor it to suit what you want. In Subsea CP1 that came out, the 2020 version, it talks about being able to vary the primary flow temperature, be it seasonally or external air temperature, so weather compensation. And it also talks about accessing the HRU settings remotely. So with the Modbus, you can do both of these things. I would like to ask how you can possibly change the primary flow temperature seasonally without having remote access to the HRU, because as soon as you try and drop that network flow temperature, if your HRU doesn't have its flow parameters, its secondary parameters changed to match that primary change, then the network will fail, because at the moment you put that flow temperature below the set points on the HRU, all the HRU control valves will open 100% and your network will fail. So you would have to go to every HRU and you'd have to adjust it prior to you making any change in that temperature in the plant room. Well, with Modbus, you can instantly change the HRUs, all of them in the building, very, very quickly. You can even set it up in the software so that the HRU will do that automatically. So you can say, for instance, I want to keep an approach temperature of 5 degrees, and the HRU will do that. And the moment the flow temperature from the energy center drops down because of changes in external air temperature, the weather compensation, the HRU will automatically drop its flow temperatures going out on the secondary to keep the stable 5-degree approach. So that's really the way you can achieve everything that's in CP1 2020. And on the final slide, and I can see Simon's getting nervous, so at the end of our 10 minutes, on the final slide, I won't just read those out, but you can see for the consultant, the installer, the ESCO and the client, there are various benefits to having that Modbus connection. Thank you.
Thanks very much, Neil. Much appreciated, and apologies for that, but I was quite clear on keeping the time. So thanks very much indeed, Neil. There were questions for you in the chat, but we'll come on to those afterwards. Tom, could we please drop Neil's presentation off, and could we please bring Adam's up from SWEP? So Adam will be talking to us about two-stage SWEP heat exchangers for improved efficiency at Wembley Park. So Adam, hopefully you're there, and I will ask you to join the stage. So thanks very much indeed, Adam. Over to you.
Thanks, Simon, and thanks, Neil. I'm still smiling after the alarm going off, so hopefully I can make it on time. Yeah, morning everyone. So my name's Adam Raymond. I'm the regional sales manager for the UK Northern Ireland at SWEP, and today is just going to give you a really short and sweet introduction to the two-stage system, or the two-stage concept, for improving district heating network efficiency. The key innovation with the two-stage system is the combining of the space heating return and the primary flow to heat the domestic hot water. So we're going to look at the traditional way of doing it and then the two-stage way, so you can understand the differences. The application is quite specific. It's centralized domestic hot water production. So we are talking substations here rather than individual HIUs. So it would be one substation, perhaps it's serving multiple floors or one floor, but this is the application. And the benefits are, compared with a parallel system, we get much lower primary return temperatures, which is really the kind of holy grail at the moment with heat networks. Constant drive for efficiency, benefiting the end users as well as the system operators. So we're going to look at that in a little bit more detail. So this is what you might call a traditional parallel system. Typical setup. It could be this is also the same for a HIU, but let's say in a substation example, we've got one heat exchanger for the space heating, and then there's the other one on the right hand side for the domestic hot water. This is still a good solution for the hot water production. We've got the primary flow entering in. You can see in the top left hand side of the heat exchanger. That then transfers its heat as it flows down to the cold water that's coming in on the bottom right and then going up. So again, a perfectly good and acceptable solution in a district heating scheme, and used quite commonly in HIUs and also in substation systems as well. With a two-stage system, this is where it gets slightly more complex, so I'll try and go slowly to explain the details. So in the bottom right-hand side is what we call the first stage heat exchanger. And I must put this out at the start, that the two heat exchangers that are circled here, that they're shown separately only for clarity of understanding. It's actually in one heat exchanger, which is another quite nice innovation. You're not having to have multiple heat exchangers on one substation skid. So the first stage, the bottom right heat exchanger, this is what we call the preheater. So cold water's coming in on the bottom right of the heat exchanger, and it's being preheated by the space heating return. You can see that coming in off the heat exchanger at the top left. It's getting a preheat sort of stage as it's going through. It then goes into the second stage heat exchanger, which is what we call the afterheater. And that's then, the temperature is then lifted up higher to the required temperature, 50, 55, 60. And that then delivers the hot water to the end user. And the key process here is that you've got two stages, two processes of transferring heat from the district heating scheme to the hot tap. And it's this combination of the preheating in stage one and the afterheating in stage two that extracts the most heat from the primary flow and the space heating return, which therefore brings the temperature lower on the primary return going back out to the energy center. On average, you can achieve, it obviously depends on the system setup, the system demand at the time as well, hot water demand and space heating demand, but on average you can achieve up to 10 degrees lower temperature compared with a parallel system. So this is obviously quite interesting for everybody that's involved in the district heating scheme, owners, operators, end users, and so on. And I think one of the interesting things with two-stage systems is, particularly in the UK, is that it introduces a whole concept of centralized hot water production. In the Nordics, two-stage systems and centralized hot water is really, really common. You don't see so many district heating schemes with HIUs or any kind of device at the apartment level. So it would be much more common that they have the substation at the in the plant room or on each floor if it's a bigger development, and that's serving multiple dwellings with space heating and hot water. So in a way, there's kind of two concepts, if you will, or particularly for the UK, we're introducing the idea of moving away from apartment level HIUs, and this isn't going to be applicable to all developments, but certain schemes might wish to consider looking at this centralized production of hot water. And with centralized production, you get some of the benefits. You're not having to knock on the door of the residents for maintenance and other issues. So it keeps everything in one place, so easy access for operating and maintenance. And again, we can achieve these economies of scale. So really, this is the short, sweet introduction to two-stage. Hopefully there's a bit of time for some questions, but there's a lot more to talk about. We have two-stage built into our SSP design tool. It's a particular range of heat exchangers. Obviously, it's going to be RAS approved as well. So if anybody has further questions or has project inquiries that they'd like to put forward, then please get in touch. My colleague, Christopher Frenfeld, some of you probably know and have spoken to him already. You can get in touch with him or myself, and we'd be happy to help you with any specifics that you might have. So I'm just going to take a look at the questions here. If there is any coming through, it doesn't seem to be any. Stephen Hart yet. Steve, we've worked with you before with on the Wembley project, so yeah, please get in touch with Steve as well. He was our substation builder for that project. Obviously, with the control mechanism for two stages is quite important as well. So choosing a good substation builder and the overall package is quite crucial. All coming through. No, I think that about covers it from my side, Tom and Simon. So I've maybe bought you a bit of precious time.
You have indeed, and thanks very much indeed for that one, Adam.
Cool.
At the moment, there's no questions for you in the chat, but I see there's a very active conversation going on between Neil and some of his people. So yeah. I'm sure there will be some questions that pop up in the chat. So for now, thanks very much indeed for your presentation. Much appreciated, and I'll ask you to leave the stage if you don't mind, Adam. Thanks very much for buying us a few seconds of time. Thank you very much indeed. Chris Bowles, hopefully you've managed to sort out the IT. Do you mind joining us on the stage, please, Chris, if you've sorted out your IT? And Tom, could you just please put up Chris's presentation, although I see Chris is typing at the moment. So hopefully Chris will either join us or sadly confirm that he unfortunately can't. So we're just waiting for Chris to join us. I think Chris is having just a few IT problems, which if Chris can't sort, unfortunately we'll have to move on to Douglas Norton. So Douglas, if you can be waiting in the rings, ready to go on, that would really be appreciated. So we'll give Chris Bowles another couple of seconds to try and join us on the stage, and if he can't, unfortunately, we'll have to move on to the next speaker. Okay, so sorry, Chris, we'll have to let your slot go. I appreciate you were having some IT problems joining us. Tom, could you please pull down Chris's presentation, and we will move on to Douglas Norton's presentation. Douglas Norton is product manager for metering solutions for SAV. So Douglas, if I could invite you to join the stage, please. Lovely, thanks. Sorry for accelerating your talk, Douglas, but unfortunately Chris was having a few IT problems there. If we pick Chris up later, we'll ask him to rejoin near the end. So I'll press start and away you go, and I'll leave you to it, Douglas. Thanks very much indeed.
Thank you. Good morning and welcome to the SAV presentation for the ultrasonic metering station, or UMS. What we're finding in the industry at the moment as we move towards net zero is that we're trying to implement new designs, new technology, and new processes in order to achieve net zero. What most of these are sort of amalgamating to, what they're all sort of joining up to, is talking about return temperature. Ensuring we have a low return temperature means that we can improve our efficiencies via lower heat losses, improve our efficiencies via being able to utilize better technologies in the energy center. And as such, we can sort of reduce costs and improve our systems. Once the design's been done, we then start looking at how do we actually get that performance? And this is where the performance gap has come in. No matter how well we design it, we need to make sure we commission and verify. When looking at commissioning and verifying HIUs, there are three different areas you need to look at. You have DHW, keep warm, and space heating. It's generally now started to be accepted the different ways that we can commission the DHW and the keep warm to ensure we get those low return temperatures. The real issue comes when we look at the space heating side. So what does the industry currently do? And those difficult questions gets asked when you have to work out how to commission and verify a space heating circuit in the summer, or when the handover was last week and we only have a very short amount of time to try and actually get it done. This is a very awkward moment for the industry, and sometimes we have to put our head in the sand and sort of wait until a winter period to go in and recommission, etc. The three modes, the three ways that I sort of see out in the industry of how we can commission. The first one, and hopefully we'll never see this ever again, is radiator balancing via the hand sensor. Making sure you've got heat at that radiator is not a good way of understanding whether your radiators are balanced properly and ensuring you've got that low return temperature. As such, CP1 is then improving that process and saying, actually, the way that we can do it is by temperature balancing. The temperature balancing, you have these external clamp-on temperature probes, and you can then join them onto the pipework either at the radiators, at the HIU, and you can see those flow and return temperatures, and you can try and balance your radiator system to that. The difficulty we have here is it takes a long time, you have to wait for it to stabilize, and then also you get into the issues of what happens in summer when the room temperatures are too hot and you cannot get that design criteria and that low return temperature to verify it's been set up and commissioned properly. CP1 does recognize this and say, actually, there are some flaws to temperature balancing, so the way that we can do it is via flow rate. But without that sort of visibility into actually seeing flow rate, the best we can do is trying to do it via calculation. So looking at the primary side of the heat exchanger, you can look at your flow rate and your delta T, and using this equation along with those temperature clamps, you can now do a flow rate calculation for that secondary side. I have tried doing this, and sort of when you're looking at these very low flow rates that you're looking for radiator circuits, so that accuracy is very hard to get a pinpoint right down what actually we're trying to measure. So what's the right solution? CP1's onto it, but they're saying that you should be looking to commission to flow rates. And this is what we can do with a direct unit. So on a direct unit, you have a direct connection from the heat network into the space heating circuit. You have, via the metering and billing regs, you have an energy meter that you have to install there, and that energy meter can measure flow and can measure delta T. So you've got a tool already installed that you have to have there to see your flow rate and your temperatures. Then looking at your radiator circuit side, assuming you're following CP1 guidance and looking at sort of installing the right radiator valves and pressure independent control valves, you can then set up each individual radiator to an exact flow rate. That can all be monitored on that energy meter, and you can commission and verify no matter what time of year, and also it's very much quicker than trying to do temperature balancing and waiting things to settle. So commissioning to flow rates is the right idea to do. The difficulty comes is when we move away from direct units. So when looking at indirect units, all of a sudden you have a plate heat exchanger separating out that heat network side from the secondary heating side. All of a sudden you're blind. You don't know what's happening in that space heating circuit. You've got a pump, you've got pressure independent control valves, you've got the different radiators, you have bypass radiators, tower rails, etc. You need to know what's happening to make sure you can commission and verify properly. This is where the UMS comes into it. So you already have an energy meter there through the metering and billing regs. That energy meter can then take in that second flow piece and a third temperature sensor. You now have visibility onto that secondary side. You can now do the same commissioning process that we would do on the direct units. So assuming you've got the pressure independent control valves on your radiators, you can set each separate heat emitter to the right flow rate, and you can verify it on the energy meter, saving time on site. You can do a full load test, making sure that the HIU is performing and sort of the settings are put in properly for that full load. One of the big benefits as well is that it's all on the energy meter. So with the energy meter, you have your error codes. So if you've got air in the system, which is a very big issue on the secondary sides, that can be sort of highlighted. But also if you have issues with potentially circulation through to blockages or pump, you can also see that with that energy meter. The energy meter digitalizes all the data. All that data is going into the energy meter, and that can be seen in two different ways. You can have it extracted out through the AMR system, through an MBUS network and through the MBUS datagram, or you can see it on the energy meter screen, sort of you know what's happening there, and it's stored internally in the internal data log of that energy meter. One of the things I'd like to point out here as well is that flow piece and third temperature probe, they're all MID approved, good for billing, but also means that it's accurate and it can go down to that 3 litres per hour. So you know that you can commission those very low flow rates going through these radiator systems. We've looked at the commissioning side, the setup side, but there's also a benefit on the ongoing monitoring. With the camshaft meter, you can see what's happening on that secondary side, but also you've got some key performance criteria. You can look at your volume weighted average return temperature for that space heating. So you can compare that with your primary side, and then you already know where that return temperature is issued may be coming from. Is it coming from a DHW because you can't see it on your space heating, or is it definitely coming from your space heating? This means that you can then send engineers to site knowing what they're going to be looking for with the right parts, so you can save visits, you can save complexity of trying to work out what's happening. So finally, we can sort of take our head out of the sand and we can actually know what's happening. So thank you very much for your attention. Please get in contact if you have any further questions. We have some various guidance on how to commission and how you can verify using the UMS. And you can always get in contact with us. So just see if there's any questions in the chat.
Thanks very much indeed, Douglas. Much appreciated. Oh, I see there's a question popped up in the chat for you. Can you see the one for Marco?
Yeah.
If you don't mind answering that one, please, verbally. No, that'd be great.
No, of course. So yeah, the configuration there's obviously a complex configuration for that. And yes, we can sort of share that with you, and you know how you can configure that meter to be able to utilize that second flow piece. You can set it up either through the camshaft software on site, or you can get it done by camshaft themselves for ordering.
Brilliant. Okay, brilliant. Well, thanks very much indeed, Douglas. I think we're done with questions for yourselves. The other ones in the chat were for Neil. Oh, here we go. Is the data visible via MBUS though?
Yes, it is. Assuming that you have the right datagram set up, and again, that we've got a datagram configuration to make sure it does come out on the MBUS network, we can get that through the MBUS. Any sort of open protocol system should be able to read that data.
Brilliant. Excellent stuff. Okay, brilliant. No Thanks very much. Marco looks pleased. So I'll ask you to leave the stage, Douglas. Thanks very much indeed. And Tom, if you can pull Douglas's presentation off. So we're running a few minutes ahead of time. So very sorry to Chris, who doesn't appear to be able to join us due to data issues. So Chris was going to speak about his Inter-Hyper 2 twin plate heat exchanger, but that will be in the slides that we circulate after the event. So we will now, thankfully, we've gained a few minutes because I'm sure we'll lose a few later on. We'll move on to the second session. The second session is customer interfaces, and I'd like to invite Ant Coates-Smith and Jan Hansen onto the stage. And Tom, could you please put up the presentation, which is about their Curve prepayment web app? And yes, if we've got time later, we will bring Chris back onto the stage, subject to IT. So Jan, over to you and to Ant as well. So thanks very much indeed to both of you.
Morning. Good morning. Thank you very much. Yeah, I'll kick off. Good morning and welcome to the Curve web app presentation for flexible billing solutions and much more. As an industry, we need to make heat networks cost effective and ensure they become an investable asset. Therefore, Inside and SAB with their technology partners have come together because our respective customers demanded a more cost-effective way to do billing. Developers and contractors wanted to pay less during install. Clients wanted to pay less during operation and are worried about replacement cost, REPEX. That is why we're proud to present the Curve flexible billing solution, which will save give savings to all relevant stakeholders, and that will be both on CapEx, OpEx, and RepEx. Most of today's solutions require two sets of infrastructure for communication, wireless or GSM, and then as per CP1 2020, also an M-Bus infrastructure. In addition to that, you also have the in-home display. The innovative step was to introduce smart M-Bus, which is widely used in existing district heating markets. And then in order to provide visibility, utilize smartphones or similar internet-connected technologies. And by adding a simple communication card which uses smart M-Bus, it opens up numerous options for data collection and communication. It means that with one simple, low-cost, open infrastructure, you are in control of your data, and you have several solutions you can adopt to comply with CP1 2020. The key is that through the use of smart M-Bus, you're in control of your data, as it is acceptable through an industry-accepted open protocol. This allows you to do performance management of the whole network, all the way from the individual flats to the plant room, as again required by CP1 2020. With the M-Bus Disconnect card, it also allows you to offer flexible billing solutions. They are as follows. Curve can offer simple monthly credit billing, or with credit billing, you can employ your own billing company utilizing the open smart M-Bus protocol. The Curve app also allows a new invention, credit as you go, and that basically means that you can switch people off through the M-Bus Disconnect facility if they don't pay, even though they are on credit. But the best thing of all, and as recommended by CP1 2020, it also allows you to offer cost-effective pay-as-you-go. So the choice is yours.
Thanks, Jan.
Thank you.
So, as Jan explained, removing unnecessary metering infrastructure has been central to Curve reducing heat network costs. Curve has evolved the existing simple wired M-Bus infrastructure to be next generation smart. To ensure that clients and residents saw no detriment to service, we developed the Curve web app and CAMP, the back office management platform which supports it. At Insight, we have over 10 years of frontline experience managing a range of pay-as-you-go metering solutions, and we used our operators' experience along with feedback from consumers to ensure that the Curve app adopted and advanced only the best features seen in the market. As a result, Curve is the first heat network pay-as-you-go web app, the app itself being the innovative solution. It doesn't link to any other piece of additional pay-as-you-go infrastructure in the home, which you have to buy, install, operate, and replace. Curve is a low-cost, flexible solution, which includes everything a landlord, social or private, would expect it to have. But Curve does not tie heat suppliers into long and expensive fixed infrastructure and service contracts. Curve ensures levels of open and transferable protocol data are built in throughout the wired M-Bus solution. So, digitalising the administration of heat billing has also delivered fully automated digital consumer journeys, which are quick, effective, traceable, and they reduce environmental impact. In developing Curve, research showed that self-service options are the preferred contact method for most consumers. So we ensured that Curve Self-Serve was designed to be quick, easy, and have a nice feel to the end user. As seen in some of the metrics here, Self-Serve can evidence some of the tangible benefits. With nearly 80% of residents accessing their account via a phone, consumption data, the most popular information, is presented more conveniently than on a wall-mounted display device, promoting greater consumer engagement with their heat use. Curve offers several multi-channel payment options, but consumers have all elected to pay from within the app, and when making payments take less than 40 seconds, it's a pretty clear, convenient choice. Now, clients are happy when consumers pay for their heat. And where credit billing was initially deployed but later switched to Curve Pay-as-you-go, consumer debt was reduced by 92% in less than 3 months. Curve has also seen a 94% reduction in customer contact, a resounding endorsement for self-service. Reducing contacts on this scale can drive further metering and billing OpEx savings too. But for those 6% of consumers who need to speak with us, call centre wait times of under 1 minute and an industry-leading Trustpilot score provide a very sturdy safety net. For vulnerable customers, Curve Safety Net really matters. Our research shows that credit-based billing options with carer facilities and nominated account guardians provide the most appropriate level of support and reassurance to this group. If your circumstances make managing an app or pay-as-you-go platform difficult, then it's a reasonable assumption that managing any in-home display or online payment is also unlikely to be suitable either. Sorry, next slide. So at Curve, we set out to reduce costs of heat networks, reducing costs by taking out cost of metering, billing, prepayment, and data analytics. And Curve has delivered. With no install costs, CapEx costs are down by 60%. With SaaS fees decreased by 50%, OpEx reduces by 20%, meaning lower customer charges for heat. With no additional pay-as-you-go hardware installed, no RepEx is required for up to 20 years, reducing RepEx by 100%. And all of this achieved whilst delivering a flexible billing solution with improved customer service. Thank you.
Yeah, and a very interesting presentation indeed, and thanks very much for talking to us about your new innovation. At the moment, I can't see any particular questions in the chat, and I'm keen to keep us working to time. So thanks again for both of you for speaking. We will be circulating the slides. Oh, we've got a question popped up in the questions section, so keen to do that. Jan and Ant, can you see the question in the questions session? I don't particularly want to read it out because it's a very long one from Marco, which is welcomed. Would you like to consider and respond to that one, please?
Yes, basically what you call it, it is a piece of control software that is sending the signal, but all the data and everything else you can get through the NBus protocol. But that particular command is basically what you call it, going through the NBus infrastructure. And if you want to have the facility of disconnecting, then obviously there is what you call a software there. But you know, you're not tying yourself into a specialist, and if you don't want the facility, you can still use your what you call it open protocol smart NBus and pull the data out elsewhere. But like with anything, you need a piece of software, and actually there is a free piece of software that you can get, and you can operate it through there. The automation of that's where we are working with saying, okay, there you need sort of the Curve app.
Brilliant. Okay, thanks very much for that. Indeed, Jan. I think we're done on the questions. So if you don't mind leaving the stage, the two of you, that's very, very good indeed. And just to mention again, the presentations and the recording will be available for this session after the event. So if I can now ask you, Tom, to put up Vital Energy's presentation and invite Glenn Harrison, their Business Development Manager, to join me on the stage. And Vital Energy are here today to present their new Glass Smart app. So thanks very much, Glenn, and over to you.
Well, good morning, everybody. My name is Glenn Harrison, and I've been invited to talk today about Glass. Glass is a digital innovation from Vital Energy, and it's a platform that accepts data from heat networks, manages that data, but also manages data from metering and billing assets. The platform was initially developed to be a class-leading metering and billing platform, but it's since developed into a much wider scope with much wider capability, and I'll touch on those in a minute. Glass takes data from connected assets, so from heat meters. Sorry, the slide's moving on its own here. Glass takes data from connected assets, so from heat meters, so from pay-as-you-go devices, and from compatible HIUs. The platform has been developed to integrate with the vast majority of smart meters deployed on UK heat networks, and also from the other prepaid platforms. The principal aim is to have one consolidated data platform to manage all of the meter portfolios. A key principle behind Glass is that the operator has choice and flexibility and freedom of the hardware choices they want to make. It also means that the customers aren't locked into a particular solution by the hardware that's already installed or specified. Glass has been developed from our own experience of managing heat networks for over 30 years, but we've also taken an awful lot of counsel from leading UK heat network operators in the public sector. That feedback has helped shape the look, feel, and the capabilities that are built into Glass. And we soft launched the platform about 12 months ago. So we now have over 12,000 users which are available to use Glass. We have 73 different developments on the platform with over 34 separate operators. So the platform is live and operational. The Glass platform has at its core a comprehensive meter and billing platform with access for both the end user and the operator through separate front ends, and these are entirely separate. The platform is accessed either via web portal or through smart device applications. For the end user, and I like the term that the guys used at Curve, it's a self-serve system. So you get full account visibility, but you also get options to communicate with the Vital Energy customer service function as well. You can view your balance, check usage, view historic consumption, and you can also review your forecasted consumption. So the app can look at the credit you might have on your account. It can look at the prevailing weather conditions local to your installation, and it can tell you how long that cash on the meter will last, given the prevailing weather conditions. So it helps you budget and decide what you need to do next with your metering, also with your account. The platform also introduces flexible payment options. So you can set up scheduled payments through direct debit links. You can also make ad hoc payments through web vend processes, as you would if you're buying anything else over the internet. But if you also want to use pay points and use cash, you can do that as well. The app gives a full audit trail of all the transactions that are taking place on the meter. So when you've gone to the shop and made a top up, you can see that money appear on your account almost instantly. So you're not having that element of doubt. There's also a comprehensive back end that sits behind the platform, and the user can access this for asking questions, looking at any particular technical issues they may be having on their system. But they can also use it as a way of accessing support if they are feeling particularly vulnerable or have issues with making payments. So again, those facilities are built in. For the operator, you can understand at a glance how your networks are performing. So you get on the front screen of the operator section, you get a traffic light system. So if you log onto your platform and you see some red icons against a particular network, you've got some investigation work to do of some potential issues or areas of concern in that network. If you've got a green icon, it's time to go and get another coffee because everything's looking pretty rosy. So performance on the network can be viewed as either financial or operational. So the computer monitor which is shown on the slide there shows our site performance tab. On the site performance tab, you get a quick glance of what energy is being consumed in that particular network or that particular installation. This allows you to determine which customers are using more energy than their peers or potentially less energy than their peers. On that particular example, you've got some fairly high spikes. So that can lead you to some other questions about perhaps network performance. Is there a bypass left open in that system which is causing that additional consumption? Equally, you can also identify those customers who are using very little energy or less than their peers. And you can start to ask those questions, those sensitive questions about affordability and whether there are potential debt issues associated with that customer. So in that sense, Glass becomes a first-line defence in providing that support and identifying those vulnerable customers who might be connected to your network. I said at the start that Glass has much wider capabilities than a standard metering and billing platform. Well, this is where it sort of really starts to hit home. Glass can be built into our vTherm range of HIUs. When Glass is linked to a vTherm HIU, it brings Hive-like capability for that consumer. The consumer can schedule their heating timescales, heating routines. They can also turn on the device remotely from the park, from the pub. They can turn it off if they've got a holiday and forgot to turn the heating off. They can do all that remotely, so it brings that Hive-like capability and control. The HIU can also report on network faults and any particular issues that might be occurring at that point in the installation. So the operator has the ability to identify issues and go back and, in most cases, manage those remotely. Our engineers can also access the HIU remotely, so they can identify any particular faults or issues that are occurring in that particular appliance. This means that should they need to attend site to repair or make a fix to that equipment, they can go there with full knowledge of the issue, with all the parts in place, which means that any service visit is resolved first time, so it reduces the disruption to consumer and reduces the disruption to the operator, but it also enhances the lifespan of the unit. When you've got glass built into your HIU, you have a two-way communication module built into the system. This means you don't need to have an endless network. This also means that we have the ability to control prepay functionality remotely as well. So you don't need to have expensive bespoke prepay hardware. So you can remove the cost of the installation of the endless network. You can also remove the cost of that prepay hardware. It's built in. I did like, again, one of the terms that Jan used in the previous presentation, which was about credit as you go. Glass also delivers that functionality. Essentially, the prepay capability is built into the unit. So, if you have a customer that has a particular need or is starting to struggle or issues with payments, and they're on a credit billing contract, you can remove that customer across to a prepay capability or a pay-as-you-go capability remotely. So again, Glass is bringing much greater capability and capacity to that HIU installation, reducing costs, but offering a far greater or a lower service. So Glass is a live system. Gives you access to live data from the devices that are connected to it. Every time you refresh your page on Glass, the platform goes and looks for the most up-to-date information. This means you get a very accurate picture of what is occurring on that particular network or installation at any given moment in time. Access to this live data helps build a very accurate picture of how consumers are using their systems. We can gain very valuable insight into how the network is operating in reality as opposed to design. And we can also use that data to influence how we manage the generation assets if we're involved in that side of the installation too. Not only does Glass give us the ability to understand how the network is performing from an operational and efficiency standpoint, we can also see very clearly how the network is performing from a financial perspective. The operator can view all the monies that are being received on that particular network periodically. They can also use that data to understand whether the operating costs for that network are being met by the tariffs that are being used to recover those costs. So again, you can use the system here to check your tariffs and make sure that they're appropriate. Glass is primarily focused, a customer-focused platform, which gives the ability to understand those customers that have greatest need. So if you're an operator of a platform, through the analytics that are available to you, you can identify very quickly which customers are struggling, which customers need additional support, and again, where you need to focus your efforts. Like I said, the platform was rolled out over the last 12 months, and so far, it's been a very, very proven success.
Brilliant. Thanks very much indeed. You're all in. Your 10 minutes are up. So thank you very much indeed. That was much appreciated. I can't see any questions in the chat. There is one, but I'm afraid your 10 minutes are up, so you'll have to answer it online. There is a question, if you don't mind. So Glenn, if you don't mind leaving the stage. Tom, if you could pull Glenn's presentation down. And then if I could invite Neil and Andrew from VRM to join me on the stage, please. Hi Neil, are you going alone today, or will you be joined by Andrew as well?
Andrew should be coming on as well.
Okay, no worries. I'll leave the both of you to go, and I'll step off the stage.
There you are. Hello everybody, good morning, and thanks for having us, guys. We just wanted to give you a brief introduction to our management offering for performance and compliance for your heat networks. For the last 4 years, we've been supplying heat network monitoring software into local authorities. And one of the things that the learnings from it was, while we were producing huge amounts of information about issues, problems, potential savings, very few clients had the ability to look into that information on a daily basis and make the best use out of it. So in order for us to assess a heat network or to take it on, if we were just providing software or we're looking at a managed service, we start with the data. So we look at gas data, energy data, take that into our system, try and enrich it with things like repairs, if they're available to us, plant room risk assessments, and we start ranking the stock based on its performance. So how good is it? What risk level is it at? Where should initial investments be made? What do those investments look like, and what's the return on those investments? And that starts us off with our clarity solution. What we then do is, with each client is obviously different based on the performance and the quality of their networks. On the top right, you can see the diagram. So we start connecting everything. So we don't look to replace anything that's there already in situ in plant rooms or in the residence flats or abodes. What we do is we look to connect it all. So where possible, we use simple IoT sensors to connect, existing gas, electricity, pumps, etc. Building management system if it's already in place, and although it doesn't have to be. And feeding in information then. So what we're trying to do is produce our best-in-class KPIs to allow somebody to monitor their heat network correctly or bespoke. So certain clients have their own needs and wants, and we create those as bespoke KPIs. And what happens then on a consistent basis is we start seeing where the faults are. So down the bottom here, you start seeing where the faults are. So this started for us with Camden, and what we realized quickly was we were spending a huge amount of time passing the information across to the client to say, hey, you've got a problem in this particular pump, you've got a problem in this heat network, and heat meters have been installed back to front and aren't operating correctly. So that sort of led us to the next level, where we realized that actually the answer, which down the bottom right, was to provide a service where we could sit on the client side, represent the client, but interact then with the third parties. So it could be the contractors on site, and the client might have their own sort of manager that needs to get passed to, or third-party contractors that are there by framework contracts. And obviously the resident sitting there as well. So is there a place where the resident could actually send information, call, complain, and how could this be taken care of on behalf? So that led us to a managed service offering, and the whole idea behind this is uptime, it's performance. It's also showing in a time where budgets are being cut, where clients can invest the least amount of money for the greatest return. And that again is part of the service that we have. One of the things then that this led us to, my colleague Andrew is going to jump in now in a second, we suddenly realized that in an awful lot of the sites that we visit and we look at when they're brand new, we see that things are not compliant, and clients are asking the question, how do we be compliant? What do we need to do apart from just the hardware itself that we might need to upgrade, or the measurement of it? What else do we need to do? So that led us then to a new solution, which Andrew is going to talk to you now.
Yeah, so good morning. My name is Andrew. I'm the compliance and sustainability manager here. And as Neil said, our kind of customer focus for a long time has been looking at your data, analysing your data, seeing what it tells us. What we're here really today to show you, and the innovation we've got for you today, is our compliance as a service as part of our managed service. Now, one of the pain points or pinch points we've encountered a lot, and we work very closely with Croydon at the moment as part of their digital Croydon project. And they understand one thing that you do get when you get the data is the knowledge of what you have to do. And one of the main things that you really have to do, as most of you probably realize, or certainly should realize, as of the end of last year, the heat network metering and billing reg amendments have been released. There's a lot of information, and every heat network owner, whether you've notified OPSS last year or not, is now required to take action, and pretty immediate action. So for those who maybe haven't caught up, the heat network metering and billing reg amendment has introduced 3 new BEIS building classes and 2 new cost effectiveness tools. And in a nutshell, what it means is that all existing communal or district heating that's not defined as supported housing falls into what they've now defined as an open class. And all buildings in this open class need to be assessed via their viability tool. There's also a new notification template that includes these 3 building classes. And the first and key deadline for all heat network owners is the 27th of November this year, at which point you must have notified OPSS of all your existing heat networks the building classes, and your requirements to install. The second deadline is next year, the 1st of September 2022, at which point you must have installed all the heat meters. So what have we done? We've added and developed over, since the amendments were released, we have developed a compliance as a service platform. And this platform is specifically designed to take you up to this reporting deadline in November 2021 and to assist you with the first step, which is the building classification. You'll see a breadcrumb across the top there that takes you through the compliance stages. It starts with building information, that classification we talked about, the network information, then the OPSS notification itself, then the period between November this year and September next year, when I'm sure you'll all be busy installing the meters that you need to install, and then obviously a compliance, a final stage here. We have compliance-specific and OPS-specific KPIs, where you can see here in this sample network, we have a number of unknown buildings which require classification, a number of open buildings which require the cost-effectiveness tool to be utilized, a number of viable buildings where we need to install, and then some exempt buildings. We have some building information, and here at the bottom you'll see in this modal the action. So the action for this building, which is in open status, is to launch the cost-effectiveness tool. The cost-effectiveness tool, there are two versions, as some of you know: a reduced input where you have your metering costs, and a full input where you may not have that information. What we've done here at VRM is integrated both of the cost-effectiveness tools and the notification template and the building classification within our cloud-based software. We've built some alerts to signpost you way towards the first deadline in November. We have dynamic tools to help you with your building classification. And as I said, we've embedded the reduced and the full input cost-effectiveness tool within the platform. On the right of that slide, you'll see the various pages from the cost-effectiveness tool. We've put this together as a combined tool, and we can take the network through the reduced or the full, depending on the data that we have. One of the advantages, I think, for you or for us is that this data is not collated and then submitted to the OPSS and then lost. It's kept with us. You can start your any of these tools, walk away, come back, obviously, as you get the information and submit that. So we are here to help. We're here to help you collate that data, to access that data, and to retrieve that data to make your next notification deadline and responsibilities a bit easier. So that's us. I'm not sure if we have time for questions or if Neil wants to add anything on that. That's our compliance as a service innovation.
Thanks very much indeed. Andrew, Neil, was there anything else you wanted to cover? You had about 30 seconds left. We haven't seen any questions to date. People have been posting them after people have left the stage, so please do keep an eye on the question session on the right-hand side. I'll give a few seconds just for people to ask questions. No, I haven't seen any pop up. So Andrew, Neil, thanks very much indeed for a very interesting presentation on your new tool, which sounds very exciting. So if I can ask you to leave the stage, and Tom, can we just check, is Chris Bowles, has he got his IT to work? Can we invite Chris to rejoin the stage? If not, we'll have to move on to session 3.
Hi there, can you hear me okay?
Yeah, can hear you good, Chris. No video,
Excellent.
but no worries. I'll leave the stage, and so over to you. So Chris Bowles from Inter, who was going to speak earlier, but we slotted him in now. Thanks very much.
That's great, thank you so much, and apologies once again for earlier today. Good morning, everyone. Thank you for listening in today. Again, my name is Chris Bowles, and I'm from Intertech. And today I'll be highlighting a particular section in the CP1. And what I've shown here says what the best practice is to allow remote access in HRU settings, and to have a solution for this, which is our centralized management package. So with this business plan, you can see the Inter Hyper 2 HRU already comes with Modbus communications inside the unit. With a Modbus register, should it be connected to a BMS system, we have iPulse, which is our own way of reading the information from the HRU. This can then be used in collaboration with a metering and billing package. We also have the monitoring data plan, in which is a dashboard that can be accessed from a PC, tablet, or smartphone, and which this will be shown in our further slides. All our HOUs are monitored by our service desk and can be incorporated into a service plan if needed. So we could then see if any faults happen within the HRU and where it's live. We have screens up at head office, which includes a huge TV in our technical area. So as things come online on the TV, it will show all live HRUs across the UK. And if it flashes up, it shows where there is a fault. Also, commissioning, we can provide this and incorporate it if needs be. Now going into more detail, what are CMM packages? The CMP hardware is a small box that's connected to the Hyper 2, which can sit inside the HRU or externally, in which it collects all the information and then sends signals via GSM. Billing packages, these will be provided by the billing provider and who they decide to use. Service, monitoring and commissioning, I've briefly covered on the previous slide. In regards to commissioning, we will quote the installer. It's then up to them who they decide to use, but once it's been completed, the HRU must be registered with Inter. Looking through these key points, more detail will be shown in the next few slides. Now, the main functions of Modbus. There is X amount of gateways and information you can pull from the Modbus register, but we feel these are the most things that people will look at. Operating temperatures, primary and secondary, how much heat is being used, and hot water usage per apartment. The actual setting of the HRU can be changed if needed. And what's important, according to the CP1, is fault diagnostics. You can see if any faults come up on the HRU. This would then cut out the first engineer visit to find out what the fault is. The performance issues you can see on graphs and charts. And then moving on to the next slide, this is the actual display of what it is. There's a dashboard providing lots of information. There's a map on it as well, showing properties across the country and can pinpoint any particular HRU from anywhere and go straight to it within seconds. Alerts can be given to see how many maintenance visits are required. And there's also a function inside the HRU which allows you to ramp down the power of it. So you can't technically switch people off, but if they want to, there's this function inside that can ramp it down to 50% of the output. So at this point, people will begin to ring us saying there's not enough hot water, and then giving us a reason to go in and then do a maintenance visit at the same time. There's some more screens to allow you to program the HRU, which shows you all the historical data of how it's been performing. More slides of what dashboards you'll be able to see. So looking at this, even though we haven't got them across the world, I've told the big chief at Inter, I've got a site visit booked in at Dubai, so I'm looking forward to a few days holiday abroad, courtesy of Inter. Yeah, I'm still waiting to see if this is going to be approved. And then moving on, our last slide, this shows you what each apartment is and what kind of status it's at. It gives you an overall picture of how our HRU is performing and what the primary and secondary sides are doing. The dashboard shows all these different functions. It shows what level of information people can see, all alerts, fault codes, what you want reporting, entire network, how it's designed, and who is actually using the equipment. All this data can be exported onto Excel for any management team reporting to show everything is all right. So the example here, apartment 48, there is a fault. So if you were to then click on that, it tells you exactly what the fault is and also tells you what recommended part that you need. And that's the end of our presentation.
Brilliant. Thanks very much indeed, Chris. That's much appreciated. I see something's just popped up in the chat. I'm not sure it's a question. Let me just check. Yep. So we will send the presentations out if you can't see them, Greg. Yeah, absolutely. We'll send them out to all users. So, Chris, at the moment, no questions in the chat, but please, if you could monitor the question session, see if there are any questions up. Thanks very much indeed for the presentation. Really very interesting. And if I could invite you to leave the stage and Tom to pull the presentation down. Thanks very much indeed, Chris.
That's great. Thanks a lot. Cheers, Tom.
So, yeah.
Yeah. All right. Yeah, that sounds right.
Excellent stuff. Thanks very much indeed. So, Tom, if you don't mind, please putting up the Aquatherm presentation. That would be appreciated. And if I could invite, I believe it's either Andy or Neil from Aquatherm to come onto the stage. Andy, Hi, cool, excellent. Thanks very much. I'll hand you over to Andy Cutting, who will present Aquatherm, an innovative solution for district energy networks.
Good morning, everybody, fellow UKDEA members, and to everybody that's taken the time out of their schedules to watch and participate in today's showcase event. Many thanks to Tom Woodward for organising the event and to Simon for chairing today's proceedings. As Simon said, my name's Andy Cutting and I'm a Business Development Manager for Aquatherm UK. I'm joined today by our Technical Manager, Neil Burtonshaw, who shall be answering your questions within the questions and answers facility on the right-hand side of your screen. For those that haven't heard of Aquatherm or used our products in the past, Aquatherm's a family business whose core values lay in being independent, determined, reliable and leading. Founded back in 1973 in a small town called Attendorn in Germany, which is just outside of Cologne, Aquatherm's now active in over 80 countries worldwide, has over 17,000 items within our product range, and manufactures over 32 million metres of pipe and over 38 million fittings annually. Our pipe sizes range from 16 millimetres all the way up to 630 millimetres. Today, we're going to look at how using Aquatherm polypropylene piping systems can provide an innovative solution to district energy networks. As I've mentioned, if you do have any questions, please use the questions and answers facility on the right-hand side of your screen. Alternatively, you can email us using the email address in the bottom right-hand side of the slide. Aquatherm and innovation. These two words have been inextricably interwoven since the company was founded. When Gerhard Rosenberg developed the first polypropylene piping system, he succeeded in creating a globally successful product. Many other innovations have followed, with which Aquatherm became the world market leader in polypropylene piping systems. Our research and development department is constantly creating innovative products and improving existing ones. Decades of experience in the production and the application of PPR pipe systems has led us to today being able to offer an innovative solution for the piping needs of district energy networks. The current ambition of continuous development has led to numerous improvements of the Aquatherm system technology, thus opening us up to new markets. Newly opened markets set a high standard of quality to make even larger demands against our pipe material. Various fields of application require the greatest possible independence of the material to be processed, and raw materials with new properties are required. Aquatherm has developed and produced their own innovative PPR materials which meet the demands of a global market for potable water, heating technology, air conditioning, chilling engineering, industrial and agriculture economy, shipbuilding, fire protection, and of course, district energy networks. The successful outcome of our research is our own innovative polypropylene material called Fusilin, and as a result, all Aquatherm PPR pipes and fittings are made of Fusilin PPR. Fusilin is respected worldwide for its consistency, chemical purity, and low environmental impact. Special heat and extraction stability are just two of the features of the Fusilin material. Its physical and chemical properties are well suited to the transfer of heat within district energy networks. Above all, material union by thermal fusion is achieved, resulting in a permanent, virtually leak-free connection. Over the next 4 slides, we'll look at the advantages that this innovative material can provide for those involved in the district energy schemes. Within Aquatherm, we take our responsibility for our employees, for other people, and for the environment very seriously. An important component of Aquatherm's corporate success is consistent environmental protection. All of our processes are focused on conserving resources, minimising the use of energy, and avoiding waste. For example, the waste resulting from our production process is recycled to the greatest possible extent and then processed into new products. This is made possible by our material, polypropylene. It's characterised not only by a long life, but also by possessing good environmental and recyclable characteristics. In addition to complying with legal requirements and regulations, we've committed ourselves to a continuous and systematic improvement in environmental performance. This is confirmed by, amongst other things, our ISO certified environmental and energy management systems. Through various measures, both large and small, we work every day to reduce electricity and water consumption, as well as CO2 emissions within the production process. The amount of CO2 produced during the manufacture of our products is far less than metal equivalents. The innovative nature of fuselling within our products leads to an extended service life, and our 10-year warranty provides peace of mind for district energy schemes. The use of Aquafirm fuselling products can be used to gain both valuable BREEAM and LEED B4 points, and we make our environmental product declaration available to everyone via our website. Now, we all know that the advantages of district energy schemes are obvious. However, the right choice of piping material is of crucial importance. With Aquafirm's innovative TI range, TI meaning thermally insulated, you get a pre-insulated pipe system for underground installation, which is ideally suited to transport heating and cooling water safely and efficiently over long distances. The medium pipe, made of either Aquafirm blue pipe or Aquafirm green pipe, is insulated with PUR rigid foam and enclosed in a jacket made of polyethylene to protect it from damage by the surrounding soil. Only fibre composite pipes are used as the medium pipe, which, due to their low linear expansion, are ideal for laying underground. All Aquafirm pipes are made of the corrosion-resistant material fuselling PPR, which is characterised, amongst other things, by very good weldability and a high inherent insulation value, and the low weight makes it easy and safe to install on site. You'll see the impressive welding times within the table on the slide, which are significantly lower compared to the welding times of equivalent materials. The innovative nature of the fuselling within Aquafirm pipes ensures flexibility to navigate around existing services, which can lead to additional time savings during the installation process. In addition, expansion provisions such as expansion loops and foam pads are not required with Aquafirm pipes due to the low expansion force of polypropylene. This enables the pipe system to absorb expansion forces when buried without detrimental effects on the service life of the pipework. This leads to a saving of material cost, the cost of civils, and reduces the disruption to residents and businesses, which can be caused when roads and pavements are closed. Aquafirm pipes and fittings are connected by heat fusion. The plastic melts into a homogeneous cohesive unit. Double the material thickness at the connection point means double safety at the otherwise critical point of a pipeline system. With innovative fusion technology from Aquafirm, you can quickly create a permanently tight connection. Unlike the image of the pipework at the top centre of your screen, the thermal conductivity of fuselling PPR is 0.15 watts per metre Kelvin, and this offers a significantly higher degree of self-insulation compared to equivalent materials, leading to lower heat loss. The innovative fuselling within Aquafirm pipes is made from a chemically inert material, which ensures the pipe is anti-corrosive, so you won't be seeing pipework images like the one on your screen. And as Aquafirm pipes are non-transparent, there is no risk of algae formation within the pipework. When using metal pipes, velocity restrictions are necessary to avoid erosion, corrosion, water noise, and damage by a water hammer. Due to the natural noise attenuation of Aquafirm pipe and the natural ability of the pipe to absorb the forces of water hammer, as well as the full bore diameter of the fittings, we can increase the velocities of the flow in Aquafirm pipe systems without compromising the ability of the pipe to prevent noise generation and water hammer. Aquafirm has published pressure loss and velocity tables to around 4.6 metres per second. However, Aquafirm has allowed engineers to design as high as 6.1 metres per second, depending on the system. The innovative fuselling within the polypropylene pipes of Aquafirm has ensured a solution to district energy schemes around the world. The advantages mentioned within our short presentation now provide an innovative choice for district energy schemes and offer an alternative against traditional piping materials. As Balfour Beatty have said in their testimonial, using Aquafirm has allowed them to build on their culture of innovation, and moving forward, I hope we can assist the viewers of this presentation and fellow members of the UKDEA in doing the same. That brings us to the end of our presentation. I'd like to thank you for listening, and I hope we've provided an insight into the innovative nature of Aquafirm pipes giving you an alternative solution for your district energy piping requirements.
Brilliant. Thanks very much, Andy. You've almost perfectly timed it to 10 minutes exactly. So thanks very much indeed. I can't see any questions at the moment for yourselves, but they may appear afterwards. Or there's one already popped up in there. So I'll leave yourselves to answer that offline if you don't mind, please.
Yeah, no problem at all.
I ask you to exit the stage. And Tom, if we can pull Andy's presentation down, and we can put up the one from Vex Oiway and Maria Kelly, who will talk about new technologies for leak detection and a case study in Espoo in Finland. So Maria, I hope you're there and invite you to join the stage, please. Just give Maria a few seconds to see whether she's having some IT problems that she can resolve. Okay. Just check where Maria's got to. If we can't pull Maria on now, we'll quickly move on, track Maria down later, and bring her in as we did with Chris. Okay, so I think for a short time, hopefully, we've lost Maria. So if I could ask Martin Overberg to come onto the stage, and Tom, if you don't mind putting Maria's presentation off, please. So Martin, hopefully you're there and you can join us. Thanks very much indeed, Martin. And Tom, if you can put up Fraser's presentation. Excellent, thanks very much indeed. Okay, so thanks very much for stepping up, Martin, and I will pass the stage over to you. Thanks very much.
Yeah, sure, no problem. And thank you very much for having me here at the UKDEA showcase. So as said, my name is Martin Overberg, and I'm working as a business development manager for Fraser in Denmark. Just to make it short, Fraser is a family-owned business, and we've been around for more than 75 years, producing high-quality products for especially the HVAC industry, but also for district energy purposes. My background for being here is I've also worked as an operations manager for a local district energy company, where we both had the production and distribution networks, and we distributed more than 300,000 megawatt hours per year. So I have a little bit of experience of running district energy systems. Well, let's look into what Fraser can offer to the district energy. First of all, we have our pre-insulated valve system for underground installations. We know we have a very, very good quality product here, and we have class-leading kV values on our pre-insulated ball valve, which of course leads to the lowest possible pressure loss throughout the system. Pressure losses that can be quite significant if you are running your systems to the limit. Then we produce valve system cabinets and covers as well for valve pits. We have IoT solutions for controlling system endpoints, that being the flow into individual dwellings or end-of-line bypasses. We can control these end-of-line installations remotely and battery powered, which means they are very, very suitable for retrofit into existing installations. And last but not least, we produce pressure independent control valves, which can be used for substations or other HIU applications. So if we take all of these products and look at it, we have a complete schematics over a simple district energy system. This is actually where we can provide our solutions to almost every part of a district energy network, except for the piping. So many of our products can be IoT enabled, which means we can deliver a lot of data from the devices. We can collect these data in a flow cloud. A flow cloud It's a platform that we have, which is a web-based platform where you can always access the data from all the devices out in the system. But furthermore, we also have the valves to actually control something out in the system. So you can take control of the endpoints like an end-of-line bypass, or you can take control of the flow into an individual household if that is needed. The communication is wireless, so it's very, very easy to get started with. We are using Sigfox technologies to carrying our signals, and you can almost compare Sigfox to a 0G network technology. It's already established. There's very, very good coverage of Sigfox in the UK, so it's very, very easy to get started and start to install all these products. It's a more a bottom-up approach. You can try it out, see if it works, and then you can scale up. Scalability is very crucial to us. We are more than happy to share all this information that you get from our system with third-party systems through an API, so you can get a more clear overview. Frase is not a big IT company, but we will definitely supply you with very high quality products which will last for a long, long time. Data, it's of course, in our opinion, something that should be set free and should be provided to the specific system where they make the most benefit for you as an operator. Yes, I'll take a little bit closer look to a case study we made where we actually started to use some data, and this is the pressure data that we were very interested in. In this case, we had a district energy operator. They started to install some of our products out there. It was end-of-line bypasses to get more knowledge about the pressure throughout their energy network. What they found out was that they have been running their system based on a calculation, and the set point was set due to that calculation. But when they started to verify what was actually going on, they soon realized that they were running their pumps too hard. And running their pumps too hard is, of course, a costly affair, but they didn't know because they didn't have any complaints. Now they have the fact to check up on it and actually to do something about it. So by tweaking a little bit on their pump operation, they were able to save more than 63 megawatt hours of electricity annually. And that actually leads to a reduction of almost 4 tons of CO2 per year. This was all just done due to some new knowledge about their pressure throughout the system. So it was a very, very small investment to gain quite a lot of benefit. So this was a case from the real world. I have plenty of more of those, but I don't have the time to show them to all. So please ask questions or contact me afterwards if you're interested in knowing more about this. So what we know from our product portfolio in Frase is that we know we have high quality products. We know that we can provide a lot of data which will increase the temperature optimization. You can temperature optimize your network. You can actually pressure optimize your network so you don't run your pumps too hard. You can get a lot of knowledge about your network, which is very, very useful if you are planning to extend your network or build it out, or maybe do some overhauling on your network or redesign it. Then it's very, very good to have some historic data telling you what the actual situation is out there. Our systems are completely wireless, which means wireless communication and battery operated. Of course, we can plug them into a socket if it's possible, but in the basis, they are wireless. What the district energy operators tend to get out of our products is actually an increased customer satisfaction, but because now they know what's going on out in the networks and they can run their network proper, and they can run them very, very closer to the limit. They don't need that much margin, which of course increases the overall efficiency of the network operation. And finally, we also look very, very much on working ergonomics with our products. The ball valve should be easy to turn. The lids, the cover lid should be easy to operate, etc., etc. So we are looking for working ergonomics as well when we develop our products. So I won't talk much more about this because I could keep on going. But if you you see or if you're interested in some of these products, please reach out to either me or any of my colleagues in the UK, and we'll be more than happy to have a chat with you about your specific needs and wants. Thank you very much.
Thank you, Martin. That's really appreciated, and thanks very much for stepping up onto the stage. At the moment, we don't have any questions for you in the chat. However, it appears that people are posting and thinking about them after the presenters have left the stage. So if you don't mind keeping an eye on the question sessions and responding to any questions raised, that'd be really appreciated. So thanks very much indeed, Martin. If I can ask you to leave the stage, Tom, if you can take Martin's presentation down, and we'll just try again one more time for Maria. So if we can put Maria's presentation up and invite Maria to the stage, and hopefully we have some success this time. And I think we do. Brilliant. Thanks very much, Maria. Indeed, Maria, do you want to say something to check you're there?
Yes, I'm here.
Excellent. Lovely. Thanks very much indeed. Over to you, Maria.
Thank you. Good morning, UK, and greetings from Finland. It seems like sometimes the VPN connections might be tricky, but now happily online. Vexve is a world-leading manufacturer of district heating and cooling valves, and for sure in your networks you do have our valves. But today we will not concentrate on the valves, but we will concentrate on completely new innovation. That is Vexve iSense smart monitoring solutions, which are specifically designed for district energy networks. And out of that product family, we will look at our iSense Pulse, which is a leak detection system. And why I chose specifically that is that we have very interesting customer case around that. I'm Maria Kalli. Please take my contact details here. They will not appear later in the presentation. And also, if you're not following Vexve on LinkedIn yet, please do so to keep up of the news about the latest innovations. To put our iSense Pulse into the whole picture, it is part of our iSense product family, which is specifically designed for district heating and cooling networks. What it means is that if it's specifically designed for district heating and cooling, it means it needs to work in the undergrounds. All of the district heating networks, they are under our cities, demanding environments, and this is what our product family can do. Secondly, they must be wireless. It's not possible that there would be wires for the communication going around the city. Thirdly, our products are self-powered. Again, it's not possible in district heating networks that you would have electricity in the undergrounds. So we are producing electricity based on thermoelectric generator, which you can see on the right-hand corner. It's producing heat or electricity based on temperature difference outside the casing pipe compared to the hot pipe inside the insulation. And fourthly, but the most important thing, that all of the products are retrofittable, because we know the district heating and cooling networks are growing slowly. Typical challenges when it comes to leak detection that we have been hearing from our customers is that, first of all, they know there is a leakage, but locating that leakage takes too long. Secondly, we keep hearing that, for example, heat cameras, which are quite popularly used, they are really good, but they do not reveal any problems in the casing pipe. So the water getting inside the insulation, not the district heating leakage actually coming out from the pipe. And secondly, this kind of heat cameras also cannot reveal district cooling leakages that easily. And usually the leakages are being recognized only when they occur, and there are very few tools to prevent those. On the right-hand side, you can see some statistics about district heating damages. These statistics are from Finland, because we actually happen to have one of the world's best statistics, so it's easy to get data from there. But what we can see is that 37% of the leakages are actually in the casing pipe connection in this kind of pre-insulated piping system. So it's a wrong interpretation that only old pipes would be leaking. We can see leak cases also in the newer pipes, especially when it comes to casing pipes. And another interesting fact is that how the leakages are being noticed. 46% external notice, 35% melted or dry area in the ground, 9% water in the chamber. It means that all of these 95% are currently being detected by a third party and not any existing system. What the iSense Pulse does is a leak detection. It is a leak detection system which is based on pulse. Leak detection itself is not new innovation. Alarm wires are not new innovation. Compared to traditional systems, which are usually based on frequency measurement, we are measuring on pulse, which is a little bit newer and it's more precise. And what is the innovation is that we can do this underground without electricity, without any retrofit problems if you have the wires inside the pipes. And with the leak detection system, you can save on pumping costs by locating the leakage fast. You can prevent corrosion caused by casing pipe damages, and you can detect and address pipeline problems already during the network warranty period, like is the sample case I will show you from Fortum network in Finland. This is the case example at Fortum network in Finland. On the left-hand corner, you can see their new biomass plant located on the left-hand corner, and they have built a new heat transmission line of 5.5 kilometers. And this transmission line is equipped with alarm wires. And on those three spots, rounded spots in the middle, there's iSense Pulse leak detection box in the undergrounds. And we are measuring to both directions so that we can, with 3 boxes, we can cover the whole network. And during the first year of operation, our iSense Pulse could detect 3 casing pipe leakages already. And it was possible for Fortum that they could fix it before any severe problems happened. And I will show you in the next slide a couple of photos from sites and how the case went forward. So first of all, we noticed that already since the beginning of the pipeline, there has been some problem at 847 meters from the measuring point. After that, we went on site, and with the portable TDR measurement, we made more precise location of leakage in 850 meters, which is very close to the point that the system was originally showing. That was dig up. First with a small window where we could see that it's obviously completely wet, the insulation. We found a crack in the casing pipe. Water, the outside water had gone in the insulation. A severe corrosion had started happening. And if this was not noticed before, it means that in a couple of years, it would have got broken also the main pipe. So this is, I would say, an example, great example on how the leakages can be prevented not only noticed when they happened, but also prevented. This was fixed. It was still during the warranty period, so the contractor, it was on the contractor's cost to make the fixing, and it was much cheaper and efficient for the energy utility to fix everything in advance before any bigger problems. Our system is using LoRaWAN network for communication, and it's also proven to work quite fine in the UK. For example, with E.ON in London, we have two systems, one in Drayton Garden Village and one in Cranbrook for iSense Opti product. And in that case, we have built our own communication network and seems to be working very fine. So no doubt also the leak detection and other iSense Pulse systems will be working great in the UK too.
Okay, Maria, you've got 30 seconds left. So was there anything else you wanted to add, or are you covered everything you wanted to cover?
There will be a lot of more things to cover, but I will remain online. So please hit with the questions on the question section, and I will be responding those there.
Brilliant, excellent stuff. So thanks very much indeed, Maria. That was a really interesting presentation. I'm sure we'll raise lots of thoughts and questions in the question sessions and chat. So thanks very much. So if you don't mind, I'll ask you to leave the stage. Tom, if you can pull the presentation down. And Chris Sykes from CPV, hopefully you're there, Chris, if I can invite you to join the stage. And Tom, if you can pull Chris's presentation up, please. Brilliant. So thanks very much indeed. Okay, Chris, over to yourself to talk about innovating and evolving using alternative pipe solutions and off-site techniques for heat network.
Thanks, Simon. Thanks for the opportunity to talk on this, and thanks for everyone for joining us today. My name is Chris Sykes, company CPV. We are pre-insulated pipework manufacturers based in the UK, based in Romsey in Hampshire. And I'm just going to talk today about innovative materials for pre-insulated pipework systems. Starting off with design considerations for insulated networks. The key areas are flow temperatures and pressures, which is usually the deciding factor for what material you use. Then you need to look down at the flow characteristics. Will it take the flows that I need? Thermal stresses of the system. Do I need to take any stress analysis into consideration for expansion? Pipe jointing, ease of installation, areas on leak detection systems, on pipework systems is the joints. So if you can reduce the amount of joints, happy days. Maintenance of the systems, and then the risks of corrosion, which is quite crucial on these systems. The next slide, I'm going to just discuss some of the flexible polymers. First off, if I just look at the greyed out area on the spider graph, that relates to steel pipework systems. Steel does have an effect on temperatures, pressures. It'll do the higher pressures and temperatures, and the size range is there. But one of the key factors is the risks of corrosion if the systems are not installed correctly. You need to consider thermal stresses on the systems, maintenance, and the flow characteristics. How we look at other systems, service pipe options as cross-linked polyethylene, polybutylene, which are flexible polymers. These systems typically will do low temperature, 82, flow 871 return for minimum 25, 30 years. They will take higher pressures and temperatures, but just for short bursts. These systems come on coils, so you're reducing your amount of joints. They are polymers, so they're self-compensating. So you don't have to consider thermal stresses, so no anchor blocks or concrete blocks. They're good with chemical resistance against harmful chemicals, and the flow rates are quite smooth, so there's possibilities to reduce your pipework size because of the flow rates a lot better. And obviously then the key thing again, no corrosion on plastic systems. They come as twin pipes, flow and returns in one case. Size range, it's up to 160 millimetre. That's the OD of the service pipe. Typically, we keep them on the shelf at CPV in Romsey for supply to projects. The next systems I'm going to discuss are rigid polymers. Aquatherm did a presentation earlier, polypropylene systems, proven in domestic and industrial applications. Again, risk of corrosion is not a problem. Ease of installation, these systems are heat fused, so electrofusion or butt welded in situ. There are training courses available for those applications. Again, they'll take sort of low temperature, 82. They will take short bursts at higher temperatures. So that's something else to consider. Typically 6 and 12 metre lengths, so you are introducing more joints into the system against the coil systems, but then the size range does have an effect because these systems will go onto bigger sizes, particularly up to about 500 mil from 25 millimetre. Again, you don't need to consider thermal stresses as it's a plastic system. And on the next slide, I'm just going to talk about particularly quite a new innovation, which is glass reinforced epoxy. This is typical for higher temperature applications. You'll look at 120 degrees C at 10 bar for 25-30 years minimum. It has a larger size range up to 630 mil. That's again the service pipes. A lot of this technology comes from the petrochem industries and chemical industrial process. Typically 6 and 12 metre lengths. Unlike polymers, it's not self-compensating, but due to the material high hoop stress, it does have doesn't have a maximum lane length like steel, particularly. No specific water treatment required for it. Flow rates are higher than that of steel due to the lower frictional losses, and the weight per metre is lighter than that of steel. Again, 6 or 12 metre lengths, so you are introducing joints to the system, which typically are spigot and socket adhesive joints, and transitions to other materials are available, typically by flanges. Diameter range 25 millimetre. It can do higher than DN630, but for the UK market, that's unusual. So that's something to consider again. So you're bringing together your temperatures, pressures, risk of corrosion, ease of installation, size ranges. So you're filling that spider graph generally as you go. And then another system, just to discuss another innovation, is reinforced polymers, which are now being used for sort of higher pressure, higher temperature systems. These are coiled systems, again, so typically on drums. They will do 16 bar at 95 degrees C. They will take peaks of 115 degrees C, but that affects the service life. So how this benefits over the rigid polymers, you are looking at, you're reducing your amount of joints. You've obviously still no risk of corrosion. The size range on this typically up to DN140, that's the service pipe bore size. That's typically 160 millimetre OD. These systems, again, self-compensating, so no difficulties with thermal stress, no anchor blocks or concrete blocks needed. Again, good chemical resistance, and the flow rates are better because obviously a plastic smoother bore system. Again, this is mainly project led, so if there's any projects out there that we can look at this, please be in contact with us. Then just to close up this spider graph, there's areas, ease of installation and jointing. To reduce the amount of joints, ease of installation, we have an off-site fabrication facility which is being used more and more for heat networks. Typically saves time on site, improves the quality, everything's tested in our works and certified before it goes out. We can do this with steel, copper, plastics. Typically people will weld up on site the steel, send it to us and we'll case it, and it will be used for getting around other services and obstructions that you find in the trench. When you dig the trench, you don't know that's there till that time. Again, this is done in the UK, so quick turnarounds on this kind of thing, which saves downtime on site, it lowers the costs, makes sites a lot safer. We can draw up different configurations of these as well for approval if need be, and it's something that is growing because of the time restraints on site. Hopefully that's been of interest. It's very brief. We've got a lot more to say, but hopefully it's condensed down. If anyone's interested, please contact, and any questions, we'll answer them the best we can.
Brilliant. Thanks very much, Chris. Much appreciated. Oh, bit of feedback there. Chris, there's one question in the chat, but I think we've overrun just fractionally. So if you don't mind answering that in the question session, if that's okay, it's from Chris Dutton about the installation integrity and testing recommendations for your systems.
Answer that in there. Thank you.
Thanks very much indeed.
Thanks everyone. Thanks for your time. Cheers.
Thank you, Chris. So if I can ask you to leave the stage. Tom, could you please bring up Flamco's presentation? And Steve, Pete, if I can ask you to join the stage with me, please, Steve. Excellent. Okay, so thanks very much indeed. And this is an interesting presentation because it's talking about benefits of phase change materials. So Steve, over to you. Thank you.
Thank you, Tom. Good morning, everybody, and welcome. My name's Stephen Peake from Flamco. We're part of the Albers Group, and Albers employs some 15,000 people with a turnover reaching towards 3 billion euros. So this presentation is on the benefits of phase change materials and HVAC systems, looking at ideas around changing storage of energy and domestic water production, as well as space heating. So a little bit of history. Phase change materials, otherwise known as PCMs, are substances that absorb and release thermal energy during the process of changing state. In the early 1900s, a little bit of history, Ellen Waterman wrote about PCMs at Yale University. He was a remarkable physicist and was appointed as the first director of the National Science Foundation in the US, and one of the first scientists awarded the Presidential Medal of Freedom. But coming up to date, in 2010, we manufactured the first PCM battery using sodium acetate as a PCM in Edinburgh. Sodium acetate is readily available. It's an excellent PCM. It is sustainable, can be recycled, and has a very long life cycle. As we know, water is a well-known PCM as well, and a typical example is a boiler heating a cylinder utilizing sensible heating. So we need a container for our PCM called a thermal energy battery, shown in the picture, and that has different sizes depending on your calculated loads. And that's used for the purpose of storing and releasing that thermal energy. It allows energy available at one time to be stored and then released at another time. So energy is being added to or taken away from either a solid mass or a liquid volume, which causes the substance temperature change. So some thermal batteries also involve a substance transition thermally through what's called delta enthalpy of fusion, otherwise known as latent heat fusion. And it's exchange in enthalpy resulting from providing energy, typically heat, to a specific quantity of the substance change its state from a solid to a liquid at constant pressure. So thermal batteries generally fall into 4 categories with different forms and applications, although fundamentally all are the storage and retrieval of thermal energy. They also differ in method and density of heat storage. A main advantage of using a phase change material is that a given mass of material can absorb a large quantity of energy without its temperature changing. Hence, a thermal battery that uses a phase change material can be made lighter, smaller, and more energy acceptably. This then energy is then utilized for space heating or domestic hot water storage or production. So PCMs utilize heat by adding energy until the melting point of sodium acetate is reached, which shown in the graph there at 58 degrees C, and then it plateaus without moving beyond its useful temperature rise. The one advantage of a PCM is that it stores 3 to 4 times as much energy in latent heat as a sensible heat of water in a hot water cylinder. Sodium acetate is an inorganic, non-toxic, salt-based phase change material. It absorbs thermal energy and releases it during its process of changing state. So when a PCM cools, it releases a huge amount of energy in the form of latent heat at a constant temperature, which is 58 degrees C, which is then converted into warm tap water or space heating. The phase transition ensures an extremely high energy density. So key user requirements nowadays are high power charge and discharge for rapid recovery and on-demand high flow rate for hot water users. So it's really important that the PCM can be rapidly charged inside the heater battery and equally heat quickly extracted. In this graph, you can see the difference between the energy density of water compared to the PCM 58 when you use in a heat battery. As shown on the graph, at 58 degrees Celsius, the energy density of the PCM is a minimum 3 times better than water. This explains why a heater battery is so compact and still has the same hot water volume as a much larger hot water storage vessel. So visually, the battery is a much reduced total volume. It's 71% compared to a 300-litre storage vessel with equal energy output. And in terms of ERP, there are also additional benefits too. So as we know, ERP determines efficiency on direct cylinders with regard to standing heat loss. This has been recognized in SAP for years as being the most important facet of a cylinder in determining efficiency. The standing heat loss is that measurement calculated either in watts or kilowatt hours per day. ERP gives performance bands within which the heat loss of every cylinder will fit, thus determining the energy rating. Experience in the boiler and white good industries have shown that customers are looking for and are prepared to pay for superior energy ratings. So products must be at worst C, and a new brand of A+, which these products fit to, have been introduced to encourage manufacturers to further enhance their products. So we look at a little bit more detail at heat batter technology. It's really matured over the century, and it's designed to provide a clean, efficient, and cost-effective thermal energy storage solution. Heat batteries are designed to work with different energy sources from renewables such as CHP, air or ground source heat pumps, solar, PV, wind turbines, solar thermal systems, biofuel pellet systems, or running on off-peak electricity tariffs, as well as directly from your boiler or directly from its own electrical source, which is shown in the diagram there. Although great for homes and apartments, they have the capacity to scale up to heat large commercial and industrial premises. Really, the ideal to make, to get a greater advantage out of the product is to optimize heater battery performance by utilizing renewable electricity, and so divert any spare electricity to the heat battery. Here it is then converted to heat and stored until it is needed, rather than the electricity leaving the home and going to the grid for minimal return. Within the unit itself is a high-powered, high-flow rate heat exchanger, 2 of them, which is immersed in phase change material and encapsulated in a red molded polypropylene cell. The red cell is surrounded by non-flammable vacuum insulation panels. These offer very good insulation in minimal space. The whole unit is then finished in a cuboid white powder coated aluminium case with pipework knockouts on any face for the ease of installation. So the heater battery provides hot water and central heating to a dwelling and be provided in multiple battery configurations. The heater battery charging demand controller is continually monitoring the central heating and hot water and heater battery temperatures and uses this information to calculate the charge state of the heater battery itself. If the charge state drops below a predetermined level, then the internal heating element is switched on. When the heater battery state reaches its predetermined level, then the heating element is then switched off. So part of that heating battery logic in the controller also includes analysis of the following parameters: the electricity tariff status, either whether it's peak or on or off peak, the utility permit to charge status, and the heating and the hot water demands in the building. So in terms of benefits, there are a number of benefits here. They're compact, can be fit in a small kitchen or unit cupboard, high-powered flow rates, minimal heat losses, 2 to 4 times less than a traditional hot water tank, saving money and reducing CO2. No maintenance, avoids the annual inspection service required for an unvented cylinder. Long lasted, they've been tested for 40,000 cycles, which is about 50 years of daily use. And I hear the bell ringing, so there's lots more in terms of advantages, including compliance with B3, as well as equally a high SPF.
Brilliant, excellent. Thanks very much indeed, Steve. That was sorry for the feedback. That was really very interesting, and I think the interesting applications to district heating networks, I'm sure, will lead a number of people to contact you after the event. So if I can invite you to leave the stage, and Tom, if you could please put up the first presentation in our next session. So this is from FVB, and we should hopefully be hearing from Todd Sivitson and also Peter Russett. If you're there in the green room, can I please ask you to come onto the stage? So Todd, I can see you. I don't know whether you're presenting on your own or you're presenting with Peter as well. Oh, you seem to be on mute, Todd. Give you a second to sort your IT out at your end. So just to confirm, this is the third session of the day. This is all to do with heat pumps, which seem to be the topic that all of us appear to be talking about in almost every meeting today. So Todd, can you hear us? It's not at the bottom of the screen. There's a microphone symbol. Hopefully that's not red. No, it's not red. And you haven't put yourself on mute locally. Oh,
can you hear me now?
Yes, perfect. Excellent.
Oh, it was so obviously Peter is not here, and he was supposed to take this first slide. So I guess we go to the next slide. We skip the presentation.
No, that's absolutely fine. However you want to play it, Todd, just use the left and right arrow on the keyboard.
Yeah, you're right. So, okay.
Brilliant.
So what I'm planning to talk about today is I'm giving you a quick background of the development of large-scale heat pumps in Swedish district heating networks, and then I will give you 2 great examples of how heat pumps can be integrated and run in district energy systems. So actually, the large-scale heat pumps kicked off in the early 80s in Sweden, and that was due to a temporary surplus of electricity from nuclear power plants. And the installations really boomed, exploded. Within 5 years, we had a capacity of 1,200 megawatt. Heat sources that we use is mainly sewage water and ambient water, which is then sea, lake, and river water, and that is 90% of the total market. When it comes to the energy supply, we have seen it has really varied from 6 to 17% of the total district heating market over the years. And we could see in the early 2000s that it was less attractive with heat pumps because high electricity prices. Now, today we see again it becomes more attractive, and one of the main reasons is that it's a lot of installations of renewable electricity sources. And that leads me to the first great example of how you can integrate heat pumps. So the combination of a CHP plant, heat pumps, and a thermal storage can really be used to balance the electricity grid. So on the left-hand side, you see a scenario where you have a lot of renewable energy sources. You run the heat pump and you charge the storage. And on the right-hand side, you have a scenario where, okay, it's almost none or very little renewables. Instead, you run the CHP plant and you discharge from the storage. And in real life, we have one example of this. It's Ryaverken in Gothenburg, where you have the integration of CHP, heat pumps, and thermal storage. And this plant has been running since the early 90s, purely on a start and stop basis, daily. And during this time period, we have only seen a few component failures, telling us that it's close to the limit with respect to mechanical wear, but you can really run a plant this way. It's quite a big thermal storage, and it's huge heat pumps as well. But the size of the storage actually makes it possible to run heat pumps full load at 6 hours only on the storage. Another great example of how you can integrate heat pumps into a district energy system is to actually use the district cooling system as the heat source. This gives you a great economy because you can sell both cooling and heating during certain times of the year. And on the right-hand side, you can see load duration curves. It's for the district heating and district cooling. And when you combine these two, you see the time period where you can run the heat pump on both cooling and heating, and it's the dark gray area there. It also tells you how you can size the heat pump. And in this example, the heat pump would provide approximately 50% of the district cooling and 20% of the district heating. Naturally, if you then also have another heat source, it could be sewage water or something else, you could run the heat pump all year long, and that would be the dotted line there. So you're not dependent on the district cooling. And if you do that, this heat pump in this example would then provide you 40% of the energy of the district heating system. We have a great example of that as well. And that's actually where I'm sitting right now here in Västerås, where we have two large heat pumps, 12 megawatt each. One is directly connected to the district cooling system to improve efficiency, and the other one is connected to the sewage water system. So you can run that pump independently on the district cooling system. However, you can also use it for the district cooling system, because when you cool down the sewage water, you run that through a heat exchanger and then to the district cooling system. And in order to make this operate well, we have two large thermal storages, one on the cooling side, 4,000 cubic meter, and one large one on the heating side, 26,000 cubic meters. And this plant has been in operating since early 80s as well. And it was rebuilt in 2005, and that was that both heat pumps were originally running on the sewage system, and in 2005 we connected one of them directly to the district cooling system. And that was really what I was going to present today. So if you have any questions, let me see.
At the moment, Todd, we've got no questions in the chat, but or in the question sections, but people have been adding them after presenters have left the stage.
I will stay.
Yeah, so if you stay in the conference and respond to any questions. Well, there is one question from Kenneth. He's put it in the chat, but we'll raise it anyway. He's asked you, isn't it time to replace some of the out-of-date HFC heat pump with more efficient natural refrigerant heat pumps? So is that something you feel you can answer, Todd?
Well, I guess that could be possible. However, they are running well, so I guess they will still be in operation. But naturally, if you would install this today, it would not be this refrigerant. Definitely not.
No worries. I understand what you're saying. You've got existing plans, but it wouldn't be that refrigerant if you're planning it today.
No, definitely not.
Okay, thanks very much indeed. Okay, Todd, so thanks very much. If I could ask you to leave the stage and Tom to pull down FVB's presentation, please. We're now moving on to the second heat pump presentation. So this is a use of a Sabro dual pack heat pump in district heating. And if I could invite Brian, and apologies if I misstate your surname, Brian. It's Brian Gohan.
Can you hear me all right? Yeah.
Yeah, perfectly. Yeah, absolutely, Brian.
Oh, good. It's pronounced Gorn, but it's fine. It's fine.
No worries. I will hand the stage over to you, and thanks very much indeed, Brian.
Okay. Well, thanks to Kenneth posing in the chat about what we should do. Obviously, I'm proposing a natural refrigerant heat pump, so that hopefully answers Kenneth's question there. So anyway, hello, good morning. My name's Brian Gorn. I'm from Sabro, UK. We distribute Sabro products throughout the UK and Ireland to local-based contractors. Through these contractors, you can get a full package of supply, installation, commissioning, and service. I'd like to thank Tom and Simon for the excellent opportunity to deliver this 8-minute elevator pitch, as we'd call it. And being an engineer, the first thing I did was to look up what would take 8 minutes to go from the bottom to the top, and it works out to be the Eiffel Tower. So that hence the picture there. The bottom left of the picture is our factory in Holme in Denmark, where we test and manufacture our compressors, chillers, and heat pumps. The silver unit at the top is our Sabro dual pack, which you can see comprises 2 units. There's a chill side and there's a heat side. It's made through 2 innovations. Firstly, the well-balanced SMC compressor can be stacked on top of the heat exchangers, so that minimizes footprint. The second thing, we have a 3-in-1 heat exchanger inside the condenser part. This reduces the need for multiple separate heat exchangers. So without these, the unit would look like a plate of spaghetti meatballs, which I thought I'd show you just to show you how bad it could be. So moving on to the next slide, if I can see it here. Here we go. So, so how do we do this? So basically, this is our range of high pressure reciprocating compressors. So to make the dual pack, we take one of our 40 or 60 bar high pressure compressors. That gives us the high temperatures, which you can see 70 degrees, 90 degrees, if you want 90 degrees. And then for the lower side of the 2-stage system, we'll put one of our chiller SMC range compressors. This will extract the heat from, if you have air source, water, ground, river source. So you can take, those sources and boost them up to 90 degrees if you so wish. So that's that slide. Press the next button. So how does it work? Now, just basically the slide on the left here, just to show you roughly what it is. This is a shell and plate heat exchanger. So your district heating water would enter at the top left at 40 degrees. It passes through 3 chambers. It passes through the plates in the subcooling section, the condensing section, the desuperheating section, and finally, it having picked up, let's say it went in at 40, coming out at 70, and back into your heating system. And using contraflow, the discharge gas will enter in the opposite corner and travel right to left, obviously losing heat and giving that heat to the water. And quickly looking at the dual pack unit here, like I said, the compressors are stacked above the heat exchangers, very low ammonia charge. So this for health and safety reasons, it's a very, very good thing. The 2-stage efficiency, these are fully factory tested. We can invite your customers, yourself, your engineer to the factory, and we will test this unit in front of you at your conditions. So you know, you can see it work before it actually goes onto your system. Also, we use reciprocating compressors here. Now, we've looked at this, and in part load, reciprocating is better than a screw compressor version. So here we've calculated about 10% of your annual energy will be saved through using the part load of the reciprocating. But these things I can go into greater detail, but obviously I'm a bit pushed. We're only halfway up the Eiffel Tower. So next thing we have, like I said, small footprint, very compact and easy to maintain. It's a bit of a fallacy with the maintenance side of things, because basically these units can be maintained in situ, whereas eventually a screw would have to be removed from the unit, which is quite a big thing. So moving on to the next slide. How does it work? Here we go. Lots of diagrams, I apologize. Top left is the diagrams to look at. If you look at we have the compressor, the circle with the diverging lines on the right hand side of the top left diagram. We have that discharging hot discharge gas at about 130 degrees C. That enters the desuperheater, where it loses a lot of its heat down to about 67 degrees. The middle heat exchanger, the condenser, and finally the subcooler takes the last bit of the heat out of the gas. So this is all in one heat exchanger, quite tidy. What does this mean in COP? If we just had a standard condenser, you would be getting about 3.98 COP in these conditions. Add the desuperheater, 4.4. Add the subcooler, 4.78. So this is a very good thing to have if you want to maximize the heat exchange in your system. So let's see, moving on to the next slide. This is the thing. Now, the question from Kenneth earlier about natural refrigerants. I mean, we all like to do our bit. We like to put our bins out. We do all our recycling. So why not in your work? Why don't you do something that's kind to the environment? These are natural refrigerants. I mean, basically, ammonia is 1 molecule of nitrogen and 3 molecules of hydrogen. So it's made from rotting plant matter, and then it returns back into the soil. It's completely natural. You'll never be able to get rid of it. It has 0 ozone depletion, 0 global warming potential. It's future-proof. You will not be replacing this gas. There'll be no regassing. The other thing that goes unspoken is that this is not a blend. In a HFO-HFC system, you have a blend of gases. If you have a leak, you will lose a percentage. Therefore, to regain your efficiency, you have to evacuate the system and replenish with brand new gas. So this is very expensive, whereas this is not a blend. good COP expectancy, industrial build 20 years plus, low ammonia charge. And top left, if a lot of this you want a simple life, we can simply give it to you in a housing with detection, extraction, attenuation, much easier on site. So going through to the last slide. Right, bottom left, this is my LinkedIn profile. So if you, now you're at your computers, type in my name in the LinkedIn profile and you will see, you'll see this picture. You'll also be able to click on my wall, my page. There are many case studies on that wall showing you all manner of applications for this system, which is very useful. We also run a CPD. This CPD lasts about 45 minutes, or let's say an hour. It's very good. It explains everything within what I've said, including more, how to get the heat sources, etc. So if you want to go onto the CPD, if you've got a company with a few people, you know, and you want to, or just contact me, we can do it, no problem. So the CPD, contact me, we've got LinkedIn. So finally, on 9 minutes, here we go. So the dual pack is compact, it's factory tested, it's very efficient, and it is the natural choice. Thank you.
Thanks very much indeed, Brian, and thanks very much for keeping to time. Much appreciated, and a really interesting presentation. We don't appear to have any particularly new questions popped up, but I'm sure they will after you've stepped off the stage, because people seem to be doing that this morning. So thanks very much indeed, Brian. And if you don't mind leaving the stage, and tell me if you could pull Brian's presentation down. And we'll move on to the final presentation of the morning, which is about large high temperature heat pumps for the UK market. And this is from Solid Energy, and I'd like to invite Ken Neal from Solid Energy to come onto the stage and to wrap up the event, please, Ken. So hopefully you're there and you can come and join me on the stage. Brilliant, excellent. Thanks very much, Ken. I will hand over to you. Do you just want to test your microphones working?
Is that right?
Perfect, excellent. No worries. I will leave the stage to you. Thank you, Ken.
Thank you very much, Simon. Thank you to Tom for guiding me through the technology this morning. Welcome to the last presentation of the day. I'm Ken Neal from Solid Energy, and we're based in Denmark, and we manufacture large heat pumps, generally over 1 megawatt, which many people may describe as very large heat pumps. Our recent innovations have been in the area of large air source heat pumps that have been designed specifically for the needs of the UK and Irish markets. This first slide consists of all the recent heat pump installations in Denmark that we've completed, and the little arrow is pointing to a photograph of our site at Ringkøbing, which is on the west coast of Denmark in Jutland. On this slide, I've listed the main characteristics and issues relating to the use of heat pumps in Denmark and in the UK. In Denmark, low temperature district heating is very much the normal method for heating buildings, unlike in the UK with a very low percentage of buildings connected. Here in the UK, we have to be careful. Ammonia is always not considered to be the first choice of refrigerants. Energy centres are often located in urban areas where space and noise considerations are a concern. Our answer has been to utilise hydrocarbon refrigerants and low maintenance scroll compressors that we believe are quieter and in many situations can be equally efficient. We can use flatbed or V-coolers selected on available space or noise level restrictions. Our new AWC heat pumps are our main innovation that we want to tell you about this morning. They are based on one skid and have the lowest possible heat pump that have the lowest possible footprint and can be located at rooftop or at ground level. Another advantage is that they come factory tested and pre-commissioned and very much plug and play. Although we want to stay at 60 degrees C flow temperature, as with all the other solid energy models, the AWC range contains heat pumps that can achieve 90 degrees C if required by the building. We can combine heat pump units to increase output, and this slide shows a visual of a 2 megawatt air source heat pump. To give you some idea of the scale, this unit is 18 meters by 12 meters. 4 heat pumps sitting on a proprietary platform provided by Configured Platforms Limited that we've been working with on a number of projects. The floor of the platform is perforated to allow flow of air to the coolers, and the acoustic screening can be solid rather than louvered. So here we have a powerful air source heat pump with the potential to be located nearer to noise sensitive areas than you first may imagine. To assist with the design of heat pump installations, we have our solid energy SCOP calculators. These are complex spreadsheets where we have to enter basic information such as peak load, operating temperatures, and location. The calculator selects the most appropriate heat pump, calculates the COP, and provides the basic data sheets for the heat pump selected. We also manufacture other air source heat pumps for different circumstances. Our AWB heat pumps use brine as the refrigerant medium when the compressors need to be located in the plant room with the coolers located at a distance. And we have the AWCL and the AWDL, which have lowest height profiles to keep planners happy. Our latest innovation has been a heat pump that can heat and cool simultaneously, and with commercial buildings in London apparently now have a greater cooling need in summer than a heating demand in winter, we can see that model being really important. We also manufacture large water source heat pumps, and importantly we have a calculator for all our models. That's pretty much my presentation concluded with regard to solid energy, but I just wanted to end on some more general points about heat pump use here in the UK. As a general advocate for large heat pump deployment, firstly, if the district energy sector is going to contribute to the government targets and utilise the rapidly decarbonising national grid, then heat pumps are the only technology available now which will allow this to happen. Clean, reliable, low maintenance thermal energy with no emissions at point of use. Many of the other presentations have shown us how operating temperatures can be lowered to increase heat pump efficiency, and the only current barrier to deployment is the artificially high cost of electricity. And I just want to leave you with one thought. The RHI is ending, the PSDS is a short shelf life, and rather than other complex admin heavy funding schemes, why don't the government consider supporting a new thermal electrical tariff that would level up the playing fields and allow heat pumps to compete with gas? I'm sure that with smart metering this would be possible, and if the plan is for 600,000 heat pumps, then perhaps a good start would be for new
So apologies, we seem to have lost Ken there. I'm not quite sure what happened, but I completely agree with his sentiments. We need to think about how we work in a world without non-domestic RHI, and also ending schemes like the PSDS. So unfortunately, I think we seem to have lost Ken. So Tom, if you don't mind putting Ken's presentation down off the screen. Thanks very much. And I'd just like to say a big thanks to all the speakers who attended today, all the speakers who spoke, all the speakers who answered questions, all the attendees, all the delegates. Thanks again. And if you enjoyed today's event, please do look out for future UKDEA events. And thank you again for attending. So thank you very much indeed. Goodbye.